Hi, I'm Steve Endersby, the Product Manager here at SolidWorks. As designers, we all aim to produce the best product we can at the right cost. Traditionally, to ensure our products have the correct performance, we build a prototype to test. If it doesn't work as we'd hoped, we modify the design, test again, and again, and again. Then, once it does work, you freeze the design and look to manufacturing to start the production process. To be honest, this is quite a wasteful process. But how do you break this cycle of test and break? The answer is simulation. Simulation is a virtual prototyping process, allowing you to test, modify, and retest very rapidly on your computer. Simulation gives you the opportunity to innovate, to try new ideas and approaches. But most importantly, simulation paints a complete picture so you can understand how your product will work in the real world. The good news is you're probably halfway there already. Once you have the CAD model, with its materials assigned, it's not such a big leap to run the simulation. Simulation doesn't replace the need for a prototype, but it allows you to visualize and communicate product performance and issues early on in the design process. You can catch and fix problems early and try new ideas to get the optimal solution. The prototype then becomes a final check, rather than a design guide. One of the biggest challenges we face as designers is trying to predict the performance of our designs after 1, 2, or even 10 years use in the field. A common cause of component failure is fatigue, and getting the balance right between strong enough and too strong is not always easy. Let's look at an everyday problem. The lever is one of the most common components in production today. You find them everywhere. They are simple yet effective, but they have to work time and time again. And as the lever moves through its range of motion, the load it sees varies, making them very susceptible to fatigue. Understanding, predicting, and negating the effect of fatigue on your design using SolidWorks simulation is a straightforward process. The loads are calculated by the movement of the conveyor and the packages. These are then used in the fatigue analysis, giving a prediction of the component's life. You can now make any design recommendations knowing you have got the design right. Trying to predict performance and improve product quality is not always so straightforward. Just think of all the items around your home or attached to your car that are made out of plastic. They have to be tough, durable, yet easy to produce and assemble. And as these parts are made in large quantities, the cost of getting it wrong can result in either too high a material cost or many failures in the field, both of which will damage your company's reputation for quality products and its bottom line. When dealing with plastic part design, you have two interdependent components to get right: the part and its mould. Even if you don't design the mould yourself, any changes you make to the part design or mistakes not discovered until production will result in costly changes to the mould. Choosing the right material for your plastic part can be equally challenging. You have to strike a balance between material strength, mouldability, and cost. Simulation helps you choose the right material without the delay and cost of a prototype mould. A wrong choice here will have a negative impact on the product quality, cost, and possible mould life. Many plastic products have snap-fit connections for easy assembly. They work well under constant load, but what happens if the product gets dropped? Will the snap-fit release? Another important consideration with plastics is its temperature. The snap-fit may work perfectly well at room temperature, but what happens if the parts get too hot or too cold? Understanding how robust your product is a very challenging problem. Using simulation, you can refine your design to ensure the correct push-in and pull-out forces, review the effects of temperature, and even see what happens if the product is dropped. In mass-produced parts, optimizing the design for the most efficient use of material is another important consideration to reduce your overall production costs. Product development is not easy and it's not direct. Simulation can really help change that. From the correct sizing of your components to the optimal material usage and even guiding the correct maintenance schedule, SOLIDWORKS Simulation is a powerful suite that will get your designs where you need it, faster and more efficiently than ever before. With its easy-to-use interface and intuitive layout, SOLIDWORKS Simulation can help your design team evaluate, collaborate and innovate to produce better products.